Hello, this is a video for EDX Statistics 1. It is the fourth video in this series and will cover the expectation of a function of a variable. We are just going to look at a linear function of x to begin with, and it's worth noting that these results do not only apply to discrete variables but to continuous variables as well. The notation here means we are not looking for the expectation of x. Rather, we have multiplied all of our outcomes by a and then added b, and we want to know the mean of these scores. Using our formulae from video 2, we can have the following. So here we have the function of x multiplied by each of their associated probabilities. Now we can simply expand that to give us the following. So now we have ax times the probabilities plus the sum of bx times the probabilities. And again, the a and the b can simply come out of these sums to leave us with the following. Now there's a couple of things going on here. The first, we have this present, so the sum of x times its associated probabilities. Now in that instance, that we already know is just simply the expectation of x. We also have the sum of the probabilities, and we also know what that is. That is 1. So we've got b times 1, which is just b. So we have the following result, that the expectation of ax plus b is the same as a times the expectation of x plus b. And this seems to make sense. If you, for example, were rolling a six-sided dice and that was your random variable, then rather than recording that score, if I doubled the score and added 5, you would expect it to double and add 5 to the mean of all my scores when I roll. And you can see that by calculation as well. Normally the expectation would be 3.5, rolling a six-sided dice. If we're generating that new score, we'd get double the expectation plus 5, 2 times 3.5 plus 5, which is 12, and that would be the new mean for this situation. We can do something very similar with variance, and I'm not going to show you during this video how to get that formula, but here is the result for variance as well. Now what might be surprising is that there's no b in our answer to this. All we are doing is multiplying our variance by a squared. But on further inspection, that also seems to make sense, because if you add a value to all of your individual outcomes, it doesn't change the spread. And as the variance is a measure of spread, it means that adding or subtracting a value to it, to all the numbers within your distribution, will have no impact at all on your variance. And we've got an a squared as the variance involves squaring. If we were to do this for standard deviation, you'd just get a times the standard deviation of x. So a quick example of one of these with the variance. We have a situation where we've rolled a dice, we're going to double the score and then add 5 to it, and we want to know what the new variance will be, the variance of y. So we know from the previous formula that we simply need to square the 2 and multiply it by the variance of x. But what's the variance of x? Well, it's a discrete uniform distribution, rolling a dice, so we can just use the formula n squared minus 1 over 12, which gives us 35 over 12. And that's the variance of x. We want the variance of y, so we're going to multiply that number by 4. And get 35 over 3. And as it says there on the screen, if we were asked for the standard deviation, you would obviously square root that and you'd find it's exactly twice the standard deviation of x. So if we consider nonlinear functions of x, there aren't standard formulas for working out the expectation and variance of these. We just have to go back to our usual formulae for finding the expectation of x. And similar to the way we found the expectation of x squared in order to find the variance, we're simply going to multiply by 1 over each of our outcomes and our probabilities. So if we consider an example, same example again, where we're rolling a dice, where each of the outcomes are 1/6, then to calculate the expectation of x, I would do 1 times 1/6, 1 over 2 times 1/6, 1 over 3 times 1/6, 1 over 4 times 1/6, 1 over 5 times 1/6, and 1 over 6 times 1/6. And that is the 1 over the outcome multiplied by the associated probability in each case, and add those up. And that would give me 49 over 120. So it's just a matter of putting the function in place of the outcome and then multiplying by the associated probabilities and adding up. And that's it. If the score is the reciprocal of the score on the dice, your expected outcome is 49 over 120. So that's the end of this video. The last video in this series is about linear combinations of random variables.